Give GPT 5.6 Sol, Claude Sonnet 5, and Gemini 3.6 flash the same repository and ask one question: which model wins? That sounds scientific until you notice that one model was allowed more reasoning, another used different tools, and the third finished while everyone was still designing the spreadsheet. There is no useful universal winner. There are workloads, constraints, and routing decisions. GPT 5.6 Sol is OpenAI's flagship lane. Its distinctive system features include programmatic tool calling, which can coordinate eligible tools through generated code, and beta multi-agent support for parallel workstreams. Claude Sonnet 5 is Anthropic's attempt to put stronger agentic behavior into the practical middle tier. It offers adjustable effort and introductory pricing below the company's flagship lane. Gemini 3.6 Flash is Google's production workhorse, emphasizing token efficiency, latency, coding, multimodality, and agent scale. Those descriptions already reveal the problem with a crown. The products are optimized around different operating points. Instead, compare 5 dimensions. First, verified success. Did the model complete the actual task, pass the tests, preserve existing behavior, and satisfy the acceptance criteria? A beautiful patch that solves a slightly different problem is not 90% correct. It is a new ticket. Second, total latency. Measure from task submission to verified result. Include model thinking, tool execution, network weights, retries, and human approvals. A fast first response does not help if the agent then spends 10 minutes rediscovering the same file. Third, complete task cost. Token price is one input. Add repeated context, tool outputs, retries, failed runs, and human cleanup. The cheapest model per token can be the most expensive model per accepted change. Fourth, tool reliability. Does the model select the correct tool, produce valid arguments, interpret failures, and stop when authority is missing? Coding agents live or die at the boundary between language and environment. Fifth, consequence. Misclassifying a support ticket is reversible. Publishing a package, rotating a credential, or deleting a database is not. Higher consequence means stronger approval, isolation, and verification regardless of which model scores highest. Now root real work. Task 1 is a nightly pipeline that reads 1,000 reports, extracts the same fields, and produces a table. GPT 5.6's programmatic calling is an obvious candidate because bounded code can filter and aggregate intermediate results without returning every page to the main model. But a smaller tier may still win if the extraction is simple and the schema is strict. Task 2 is an interactive coding session with a developer who wants a substantial refactor, fast iteration, and control over effort. Sonnet 5 is a sensible first route. The important test is not whether it writes convincing plans. It is whether the repository's tests and the developer's review show that the plan survived contact with the code. Task 3 is a high-volume multimodal queue that reads screenshots, classifies routine states, and triggers reversible actions. Gemini 3.6 Flash is a sensible candidate because latency and token efficiency multiply across every turn. Escalate uncertain or risky cases instead of forcing the workhorse to become a philosopher. Task 4 is an ambiguous production incident. Do not route it by brand. Route it by a live evaluation. Give each candidate the same repository snapshot, logs, permissions, time budget, and success criteria. Require a diagnosis, a safe remediation plan, and evidence. The winner is the model that helps resolve the incident without inventing confidence. A good router can start simple. Classify the task by risk, ambiguity, expected tool count, context volume, and latency requirement. Send routine, high-volume work to the efficient lane. Send complex synthesis to the stronger lane. Escalate when verification fails, evidence conflicts, or the agent reaches its step budget. Never let the model grade its own escalation. Use observable triggers, a failing test, conflicting sources, repeated tool errors, low-confidence structured output, an action marked sensitive, or a change outside the permitted scope. Self-reported uncertainty can help, but it is not a safety boundary. Then freeze an evaluation set. Use 50 to 200 tasks drawn from real work. Include ordinary successes, annoying edge cases, malformed tool results, stale documentation, permission denial, and prompt injection. Keep the repository state and tool versions reproducible. Score pass or fail on behavior. Record partial diagnostic signals, but do not let a friendly writing style compensate for broken code. Also separate the model from the scaffold. If Sol gets programmatic calling, Sonnet gets a mature coding harness, and Gemini gets a different browser environment, you're testing complete systems. That can be useful, but label it honestly. A model comparison and a product comparison are not the same experiment. Vendor benchmarks are evidence, not arbitration. OpenAI, Anthropic, and Google choose different evaluations, settings, and cost assumptions. Even a shared benchmark can hide differences in tool access and reasoning budget. Your router should therefore be empirical and temporary. Rerun the evaluation when models, prices, tools, or prompts change. Sonnet 5's introductory price has an end date. Model families update. A permanent policy built from launch week becomes archaeology surprisingly fast. Before switching production, run the candidates in shadow mode. Let the current system make the real decision while the challenger attempts the same task without authority. Compare outputs against the eventual verified result. Shadow runs reveal tool incompatibilities and latency tails without asking customers to participate in your benchmark. Promote one task class at a time and keep a rollback route when the new model begins expressing its personality through incident volume. Here's the practical verdict. Try GPT 5.6 Sol for deep, tool-heavy synthesis and workflows that benefit from programmatic coordination. Try Claude Sonnet 5 as an agentic coding default when its verified success justifies the full task cost. Try Gemini 3.6 Flash for high volume, latency-sensitive multimodal agent steps with escalation for uncertain cases. Then let your evidence overturn those assumptions. The best AI stack in 2026 will not be loyal to one logo. It will route each job to the cheapest, fastest system that clears the required quality and safety bar. Crowns are excellent for thumbnails. Routers are better for production.